day. This glass disc is an immortal library. Every photo you've ever taken, every movie you've loved, every book ever written. It's a strange thought, isn't it? Everything is stored on materials with a depressingly short lifespan. The magnetic tapes used for massive archives have to be painstakingly recopied every decade or two. Our entire civilization's memory is incredibly, terrifyingly fragile. But what if we could write our story into a library that would outlast humanity itself? What if this small, unassuming piece of glass could hold terabytes of data? This isn't science fiction. This is a 5D memory crystal, developed by initiatives like Microsoft's Project Silica, and it might just be our best shot at building an immortal library. We are creating data at an absolutely explosive rate. That's every email, every satellite image, every medical record, every last cat video. And we trust this digital ghost of our world to storied media that was never built to last forever. The problem is something called data rot. Take magnetic hard drives, the spinning disks in many computers. They store data using tiny magnetic areas on a platter. Plus, they have moving parts that just wear out, but the memory cells they use can only be written to so many times before they give up. This creates a hidden crisis for anyone trying to preserve things long term. For archives, libraries, and even movie studios, it means a constant, expensive, and unsustainable cycle of migrating data. Warner Brothers, for instance, was facing this exact problem with their huge film library. Which is a big reason they've teamed up with Microsoft to find a solution. The real issue is that we're retrying to build a permanent record of our civilization on a foundation that's designed to be temporary. We're writing our history in the sand, just as the tide is coming in. But what if we could write it in stone? Or even better, in glass. Section 2. The Hero Quartz Glass. This is where the story takes a sharp turn. It's this, a small, transparent square of fused silica, or quartz glass. It looks simple, almost boring. But using a revolutionary technology known as 5D optical data storage. The early breakthroughs happened at the University of Southampton. This research laid the groundwork for huge initiatives like Microsoft's Project Silica. So, why quartz glass? Because it's one of the most durable materials on Earth. It's chemically inert, so it doesn't rust or decay. Researchers at Microsoft have put this stuff through absolute torture. They baked it in an oven at 500 degrees Celsius, boiled it in water, scoured it with steel wool, and even microwaved it. Through all of that, they didn't lose a single bit of the data stored inside. And once the data is written, it takes zero energy to just sit there and keep the data safe. Section 3. How it works. The 5 dimensions. So, how on earth do you write data into a solid block of glass? It's called 5D storage, not because it's in another dimension, but because it uses 5 different properties to cram information in there. Think about a normal CD. A Blu-ray adds a 3rd dimension by stacking a few of these layers, which fires pulses of light that are almost unimaginably short. We're talking a quadrillionth of a second. These ultra-fast pulses create permanent, microscopic structures inside the glass, called voxels. You have the 3 spatial dimensions we all know. The voxel's location eats X, Y, and Z, position inside the glass. But the laser can also control 2 additional optical dimensions. By controlling these 5 variables for every single voxel. This is what unlocks the incredible data density. While early university research talked about a theoretical 360 or even 500 terabytes on a disk, the current practical system from Microsoft's Project Silica can store up to 7 terabytes on a platter the size of a drink coaster. To read it all back, a computer-controlled microscope shines polarized light through the glass. AI-powered software then decodes the information based on how the light is changed by the size and orientation of each tiny structure. Section 4. The conflict and the breakthrough. But there was a huge roadblock. The idea of storing data for millennia is great. A 2021 study from the University of Southampton, at that speed, writing a few terabytes would be an exercise in extreme patience. The solution wasn't one single aha. Researchers discovered new ways to use weaker, faster laser pulses to create the nanostructures without causing heat damage to the surrounding glass. This, combined with systems that allow for parallel writing, using multiple laser beams at once, is dramatically speeding things up. Microsoft is now confident that its Project Silica system can hit write speeds comparable to current archival systems, like magnetic tape disks, isn't meant to replace the superfast SSD you use every day. Section 5. The wow factor, an immortal library for humanity. So, what does all of this really mean? We're moving from theory to reality. IMS. And successfully archived the entire 1978 Superman movie on a small glass platter, a fitting choice for a technology nicknamed the Superman Memory Crystal. That single piece of glass now holds the film, safe from decay for thousands of years. Researchers at the University of Southampton have already stored the entire human genome on a 5D memory crystal. That crystal is now housed in the Memory of Mankind archive, a time capsule in a stable salt mine in Hellstadt, Austria. To make sure whatever intelligence finds it can understand it, another organization, the Arch Mission Foundation, is dedicated to creating a permanent archive of human knowledge across the solar system. In 2018, they sent a small 5D quartz disk containing Isaac Asimov's Foundation trilogy into a permanent solar orbit aboard the SpaceX Falcon Heavy rocket, tucked inside Elon Musk's Tesla Roadster, and the technology is still evolving. Conclusion: we live in a world of constant change. Our history, our art, our science, it all exists as a fragile sequence of bits on media that is destined to fail. It's a technology that doesn't just store data, but preserves it across geological time, to ignore the decay of centuries, and to hold the story of humanity long after we're gone. It's not just a better hard drive. If you are interested in these subjects, until next time, keep exploring.